Very good afternoon. कैसे हो? Yes. Okay. Last class, if you remember, we have studied about the interior of the Earth, especially with the help of the indirect sources. Today, what we'll do is, this is the next class of Geography Optional, where we will be studying the further topics. Now, these are your preparatory classes or the basic classes, जहाँ पर NCERT for Geography Optional, and these are considered to be the basics. On these basics, you will be able to understand the further topics. Right? So, if you remember last class, we have dealt with the topics such as the sources, direct sources of interior of the Earth. On this, we have studied direct sources and we have also studied indirect sources, right? And more specifically, we have concentrated on the seismic waves. But today, what we'll be doing is, we'll go deep into the interior of the Earth and then study more in detail, right? Online, if you do have doubts, please post it in the comment section, right? Okay, so you tell me what are the different types of waves that we have studied. We have studied the earthquake waves or the seismic waves. In the seismic waves, we have studied about the body waves, and then we have studied surface waves. Body waves are of, can you name the body waves? The body waves are P waves and S waves, and surface waves are R waves and L waves. Out of all these waves, which is the most dangerous wave? L wave. And any surface wave is a dangerous wave, but when it comes to the P waves and S waves, these are called as body waves, and S waves, they are called as surface waves. Yes, surface waves we have studied in the form of R wave and L wave, right? And you also got to know the propagation and the movement of the waves. And you know some nature and characteristics of these waves. That is nothing but P wave can travel through all the mediums, S wave can only travel through yes, only through solid. It cannot travel through liquid medium. Same is the case with the surface waves. So broadly speaking, by using these waves, we got to know about the interior of the Earth. And today, we are going to learn about the interior of the Earth by using these seismic waves. If you remember, I told you that the Earth has 3 different layers, right? You have the outer layer as crust, then you have mantle, then you have core. So I also told you that as you go deep into the interior of the Earth, you will understand that our Earth interior density keeps on increasing, right? Now, these studies are done by various people. It is done by various people, and their contributions are given in the name of their discontinuities. Discontinuity is nothing but when you start to move from one layer to another layer, in between, you got to see some variation. Matlab, continuity of the density of the material is not there, but when you go deep into the interior, there you got to see some variation. And then the layer at which you got to see this variation is nothing but discontinuities. Those discontinuities also we will look into, right? And broadly speaking, your Earth will be having 3 different layers, and the 3 different layers can be subdivided into multiple layers. And the composition of the Earth's composition jo hai, it can be divided on the basis of chemical composition and on the basis of mechanical composition, right? You might have come across the word asthenosphere, barysphere, mantle, inner core, outer core, like the different classifications are there. So what we'll be doing is, we'll be trying to understand the various layers of the Earth. So see, your Earth has one crust. On this crust, you have mountains, you have plates, and you have plateaus also, right? And you may have some depressions, right? This is how your Earth is. And broadly speaking, ये जो Earth है, it can be of various landforms you got to see. Now, the layers of the crust, as you go into the interior of the crust, the material keeps on changing. And as the material changes, the seismic waves that have come out, the seismic waves speed also changes, right? I told you, the more the density of the material, the higher the speed of the seismic waves. So if the density is more, obviously speed will be more. Now we got to understand that the waves, whenever they are coming from the material under the ocean, which is primarily made up of basalt. the speed of the waves are different. And same, when they came through the continental crust, the speed of the waves are different. By using these at various seismographs, we got to understand that interior of the earth has different layers, right? So the broad classification of the interior of the earth is divided into one. It is the crust. This is your crust. Then you have mantle, and then you have core. Now within this, you can divide the crust into, on the basis of ocean. Imagine, ये आपका ocean है. Ocean also has a crust. And this is called as oceanic crust. Right? ये आपका oceanic crust है. Now, beneath the continent, imagine these are your mountains, these are your continents, or the place that where we are living. So, the thickness of the continental crust is something different than the thickness of the oceanic crust. Okay? It is like this. This is the thickness of the crust. Now, this is called as continental crust. Right? Now you see, if you start to dig within the deep into the deep floor of the ocean, hardly dig for 6 to 7 kilometers, you will touch the magma. But start to dig a bore well. Today, the deepest bore well which we have dug is up till 12 kilometers in the Kola Peninsula or the Kolar mines in the Russian region. There, you still don't get any volcanic activity or magmatic activity. Why? Because the thickness, until the depth of the thickness of the crust is more on the continent than in the ocean. Now the material which is made up of the crust is different, and the material of the oceanic crust is different. And see, comparatively, if you compare the oceanic crust as well as the continental crust, which is more denser? It is oceanic crust. The density of the oceanic crust is higher. Density is higher, and the density of the continental crust is less. As compared to what? As compared to these two. Now what are these materials made up of? The materials are made up of one. This is made up of granite. Okay? And other different materials are there, igneous rocks, that I'll tell you in detail in the further classes. Now broadly, this material is made up of basalt. Right? So basalt has higher thickness and granite has less thickness. See, there are also both these two rocks, both are igneous rocks. Okay, granite bhi igneous rock hai, basalt bhi igneous rock hai. Igneous rock means they primarily came from the fundamentals of volcanic activity. In simple terms mein kaha gaya to. So, why is this more denser? Why is this less denser? Can you tell me the reason? Pressure of what? Why is oceanic crust more denser than as compared to the continental crust? Reason. If online, if you know the reason, please post it into the comment section. Why is oceanic crust more denser and continental crust less denser? Yes? Because it is, what is deeper? आपका कहना ये है, सर oceanic crust काफी deeper है. So let me redraw the same, let me redraw this. For example, let us try to understand this too. What I've done is, I've taken a column of earth. This is what I'm carving it and I'm redrawing it. So let's see, for example, this is your ocean, and I tell you this is your mountains. Right? So I've carved this. Right? So आपका कहना ये है, सर ये जो ओशनिक क्रस्ट है ज्यादा वेट है उसके ऊपर, ये है, देन ओके, इनका कहना ये है, सर ये मैंटल के पास है. Okay, let me draw the crust diagram. Imagine ये जो thickness of the crust है, it is less, but this thickness will be like this. So विपुल का कहना ये है, सर ये mantle के पास है, इसीलिए thickness ज़्यादा है. Is this true? इसीलिए density ज़्यादा है. फिर रुको. Now as per your logic, let me tell you that you also have, this is all the mantle. ठीक है, imagine this is your mantle. Right? But this is more near to the mantle. This material should be more thicker, right? More denser, right? As per your logic, his logic is that, sir, see, this is more near to the mantle, so that is why it is thick. Now this material is far away from the mantle. This is less thick. Now my question here is, if this is near to the mantle and this is only till a depth of 5 kilometers, it is there. But this, it can go up to 30, 70 kilometers also. Now this should have more density by the same logic. See, you're partially correct. Before that, ये समझने के लिए ना आपको volcanism भी समझना चाहिए, right? The answers to these topics lies in the volcanism. Now volcanism says that any material which is coming from deep in the interior of the earth, that material has more density, right? And they are based on the silica composition. देखो, silica is nothing but मिट्टी. अगर मिट्टी ज़्यादा है, it will be viscous in nature. Viscous means it is like honey. Say there's more amount of mitti composition in this, silica content in this, and there's less amount of silica content in this. And silica is the primary reason why it is having different kinds of densities. And also the cooling, at what rate is it cooling? See, usually before I explain this, I have to tell you a different concept. That is crystal cooling. Imagine that you have a volcano coming out. See, your volcano can come out from this depth. There can be volcanic material which can come from this depth. There can be volcanic material which can also come from this depth. Right? Now, the deeper the volcanic material, the denser the materials are. No matter what, while they come into the journey, see, this material can be easily, for example, the thickness is what? Hardly 5 kilometers. Now the material can easily come out of this. But iska density kya hai? Zyada hai. Look at the continental crust. Continental crust thickness is more, but density is less. So a material, volcanic material, while it is coming out, it will be hot. Sometimes it is hotter than, it can even melt the continental crust as well. So while it starts to come out, imagine this volcano, while it is coming out, it makes contact with the continental crust as well. Now, as its journey starts from one layer to another layer, it gets mixed with silica. Right? This is getting mixed with silica. Silica is nothing but mitti. If it is getting mixed with silica, the volcanic material cannot move that easily. It will be viscous in nature. Right? But you do not have much amount of silica here, so they do not directly mix. The volcano that comes out is fluidic in nature. और उसका temperature, इन दोनों में temperature किसका ज़्यादा होगा? Which volcano will be having more temperature? Is it basaltic volcano or continental volcano? Basaltic. May I know the reason? Yes. So इनका कहना है, सर यहाँ पे सिलिका मिक्स हो रहा है. सिलिका मतलब मिट्टी, ये मान के चलो अभी तो. In detail, I'll tell you in the further classes. So if silica is getting mixed with this components, in that case, its temperature will get diluted and it gets viscous. It gets difficult to move out. That is why, on an average, when you see a viscous volcano is nothing but a violent volcano. Now here, they are coming from depths and easily movable. Silica is not mixed. Composition of silica is less. So that's why it is hot and fluid. So a basaltic volcano will always have high temperature, very high temperature, as compared to the volcano which is having on the continent. It is continental crust volcanoes जो भी हैं, वहाँ पे thickness ज़्यादा होता है. viscosity, it will be more. The thickness is also one of the reason there. Now coming to the rocks that are formed here. See, basaltic rock पानी के नीचे है. So when it comes in contact, when a volcanic material comes in contact, will it cool fast? Or when a volcanic material, when it is coming in contact with these rocks, which one will cool fast? Of course, this will cool fast. It will take some time, right? So any material which is cooling at a faster rate, will its crystal size be bigger or will its crystal size be smaller? Q bigger, Q smaller. देखो, crystal big होने के लिए ना, it need to cool down slowly. If a crystal need to be small, it will not get much of a time to get bigger. छोटे crystals will be formed here. The size of the crystals will be small. The size of the crystals will be big. It is because it cools down slowly. It cools down fastly. And the material which basalt comes from deep in the interiors of the volcanic material. I'll show you in the geography optional. You will study in very detail, very detail about a particular series. Have you ever heard of Bowen reaction series? देखो, Bowen reaction series ये कहता है, this is the depth profile and temperature profile, right? See, in the volcanism you learn this. Today I'm only giving you an introductory into this. Your Bowen series reaction says that if the temperature is higher of a particular volcano or particular rock, then you will find mafic rocks, right? If the temperature is lower, ठीक है, around 650 degrees, 600 degrees Celsius, you will find continental rocks, that is granite, right? And usually, as you go deep into the interior of the earth, the temperature of the earth increases and also the density of the earth increases. So, see, if there is a volcano that is coming from very deep and their temperatures are in the range of 1400, 1500 degrees Celsius, and with the same temperature, if it is coming onto the surface and cooling, then we will see ultramafic rocks, which are of comatite and peridotite. But what do you see on the continental crust? Which type of rocks? I told you, granite. Granite देखो, granite का temperature जो है ना 650 degrees Celsius की range पे होता है. And then you see at this temperature these rocks are found not at a very depth. That means volcano, while it is coming out, it got cooled at that temperatures from that. That is why you get to see granite. But लेकिन ocean के नीचे कौन सा था? Under the oceans, what kind of rocks you get to see? You get to see the basalt. Where do you see the basalt? Basalt is in the range of 1000 degrees Celsius, right? That means here, as and when a particular volcano gets mixed with silica, the temperature drops and their viscosity increases. It means it will get very difficult to move. It moves, it's like honey, right? This is how it is. And on this broad categories, as the thickness changes, density changes, temperature changes, they are all interlinked. So this we are going to study in very detail, but now what you have to understand at this point of time is, the more the temperature of the interior of the earth, the more the basic rocks are present, right? The lesser the temperature of the rocks, the acidic content of the rocks will be more. Now you look, basalt भी एक igneous rock है, granite भी एक igneous rock है, ठीक है? Granite मान लो, pegmatite, gabbro, ये सब rocks, they are all igneous. Now come back, here you'll get to see of various different types of rocks. And look here, this is broadly your continental crust thickness and this is your oceanic crust thickness. Imagine this is a big mountain, maybe Himalayas. Under the Himalayas, the thickness, if you dig deep down until 70 kilometers, you'll still get the continent itself. But on the oceans, hardly 5 kilometer thickness, right? Now the right logic, why is your basalt thickness? It is because silica absence. silica absence and density is higher, it is because silica content is less. इसमें silica content is more. That's why density. Now come back. See, your earth is broadly divided into, I told you, this is your oceanic crust and this is your continental crust, right? Now, beneath the crust, you will find mantle. It's like this. Imagine this is your mantle. Your mantle can be divided into 3 different layers. 1, upper mantle, intermediate mantle, and then inner mantle. In some books you will find that upper mantle, lower mantle. In some books you will find about these 3 layers. And then you go in deep into the interior of the earth, you will find this is your core, this is your outer core, and this is your inner core. As you go deep into the interior, 1, I told you, density increases. Temperature kya hoga? Increase. These are the 2 things we got to know. Now when the density of the material increases, what happens to the speed of the seismic waves? The speed of the seismic waves will also increase. The velocity of them increases. Now by we studying about the seismic waves, we got to know about there are different kinds of layers. And out of all these layers, which is a liquid layer? Outer core is a liquid. Right? Inner core is solid. Okay? Inner core is solid. Rest of the interior of the earth is solid itself, but there is another layer called as asthenosphere. Now, where is asthenosphere found? Asthenosphere, it is found in the upper part of the upper mantle and some part of the intermediate mantle. This is where you will find asthenosphere. ठीक है, ये asthenosphere है क्या? Asthenosphere is like a molten material, semi-plastic in nature. It is neither solid nor liquid, but somewhere it is like a plastic. ठीक है, chewing gum more exactly, right? So, if at all these kind of material, it has some elasticity. Suppose if I put more material on this, your asthenosphere also bends like this. Okay. See, there is more weight here, your asthenosphere will also bend like this, right? But you have to understand that the density of the material of the asthenosphere is more as compared to the continental crust and as compared to the oceanic crust. Now, I have told you that Earth is divided into crust, mantle, and core. But now I am telling that there is a different layer called asthenosphere. Where did this asthenosphere come? Now, what is the composition of the asthenosphere? See, there are 2 different compositions. One is chemical composition, other is the mechanical composition. Whenever you find the word asthenosphere, it is an indication that it is the mechanical composition of the Earth, right? So, in this asthenosphere, it is, or else, plastic kind of material. To be molten plastic kind of material, right? Now, the theory of asthenosphere came up little later. Earlier, people were thinking that our entire continents were floating on the oceans. This is what earlier people thought. But later we got to know that our continental crust, or the lithosphere, to be more specific, we can call the lithosphere is floating on the asthenosphere. Now, what is this lithosphere? The layer above this layer, which is above asthenosphere, is called as lithosphere. And this layer is called as asthenosphere. Asthenosphere is a weak layer. It is not a strong layer, very, very weak layer. Astheno means weak, right? Come back. Now, As and when the seismic waves started to move, when they reached the astronosphere, their velocity increased. It was 6.1 kilometers per second it was, and then immediately when they reached this layer, they got to see 6.9, 7.1, like that. That means the density of this material is more. This is what we got to know. And rest of the layers which are there on the above the surface of the earth, they are lithosphere, and this lithosphere is broken into pieces. Right? Imagine ये जो lithosphere है, it might have broken into pieces like this. ये एक piece हो गया. This is a different piece. This is a different piece. And each of this piece is today called as plates. ये बन गया आपका plates. Right? If it is made up of continent, it is called as continental plate. If it is made up of ocean, this is oceanic plate. But for example, there can be plates which are made up of ocean also. They are also made up of continent. But whichever is dominant on that dominance base, we call that as oceanic plate, or we call it as continental plate. Right? So we'll come back to these plates little later. Now come here. Astronosphere. देखो, ये जो plates है ना, we are studying about this particular layer currently. I did not go into the interiors now. We are broadly studying about only these layers. See, sometimes what happens is that your ocean density, the material plate density of the ocean sometimes will be more than astronosphere. When the older the oceanic floor, the more will be the density. And sometimes that denser material will go and sink into the astronosphere, or it will cross the astronosphere, and then you get to see volcanic activity or the destruction of the plate. This we'll study in little more time. Come back. Now, you get into the little more interiors, you got to see a layer called liquid outer core. But why is this layer liquid in nature? Why is the outer core liquid, inner core solid? Anyone ever thought क्या reason हो सकता है? Heat. See, as you go into the interior of the heat, you will realize that there is more temperature in the interior of the earth. So heat तो सबसे ज़्यादा ही है. I'll tell you the temperatures here. Look here. Kilometers and all बाद में याद कर सकते हैं. पहले logic समझ लो. So here your outer core is 2,200 kilometers, inner core is 1,250 kilometers, right? And when you broadly look into the temperatures are near about 5,000 degrees Celsius there. And inner core में the temperatures are as hot as the sun's surface temperature जितना है. Heat तो है, heat तो दोनों में काफी ज़्यादा है. But why is the outer core liquid in nature? Why is the inner core solid in nature? Reason. Online, if you're watching it, please mention into the comment section. Yeah. What could be the reason? See, to understand the reason here, you need to understand a concept called partial melting. ठीक है? Partial melting होता क्या है? See, you know that Earth is a composition of rocks. These rocks are in the solid format on the surface, but when you go into the inner format, they are molten in nature. Now, every rock has, okay, you define me what is a rock first. What is a rock? Yes, what is a rock? Then only it will be easy for us to understand. Imagine this is a rock. ठीक है? ये जो rock है, rock is nothing but it's a collection of different minerals. Right? ये A, B, C, D, E, F, G, H. Like that you have multiple minerals within it. And each mineral is nothing but a collection of elements. Right? Each mineral will have collection of elements. For suppose, A can have a melting point of 500 degrees Celsius. B can have a 200 degrees Celsius पे melt हो सकता है. F can melt at 1100 degrees Celsius. right? And now I have, what I've taken is that I've taken this rock. Imagine I've taken this rock and I was giving a temperature of near about 600 degrees Celsius. And I've put this rock here, and so here you have A with 500 degrees Celsius temperature melting. This is 200 degrees Celsius, B, and you have your F, which is at 1100. And imagine this is C or this is D. This can melt at 900 degrees Celsius. This can melt at 1200 degrees Celsius. Okay. So I, J, H and they also melt at same temperatures. Maybe at ये सब चीजें 600 degrees Celsius पे melt होगा. So now you tell me, will the entire rock melt? No, it won't melt. What happens to the rock? Rock will only be partially melted. Now whatever the melted material, it will have certain thickness, it will have certain temperature. There will be solid material. Now temperature is higher, it will be melted only when these rocks, while they are traveling in the interior of the earth, they will melt at that depth. Look, it's like this. Suppose this is your interior of the earth, right? ये आपका interior of the earth है, and I told you this is your asthenosphere. ये सब आपका lithosphere है, ये asthenosphere है, and this is your mantle, outer mantle, this is your outer core. This is your inner core, right? Suppose there is a particular rock which is present above the surface of the earth, and finally that rock has made itself to reach into these areas. The temperature here is maybe 700, 800 degrees Celsius or 900 degrees Celsius. But still, there are materials which are present in this rock which can melt at 1100 and 1200 degrees Celsius. So what happens to this rock? Imagine this rock, while it is going down into the interior of the earth, it only gets partially melted. But still there are materials which need high temperatures. That material, it will go little down here and it will get melted here. Even then, if there are compositions of materials which can melt at little more higher temperature, it will slowly go here and finally it will reach outer core. At the outer core, the temperature and the pressure is very conducive, and also the purity of the materials. As you go into the interior of the earth, the purity of the materials also increase. Now you can ask me, sir, why is this material going down? It is because of partial melting. ठीक है? समझ गया partial melting? So, as and when this partially melted rocks, the finest and the purest materials are the ones which are found at the core. इस rocks में ना, इस level पे impurities बहुत होते हैं. Impurities means it may not be of a single type of rock. मिट्टी हो सकता है, silica हो सकता है, some rust हो सकता है, any material. But when it reaches to the core level, the temperatures are very high, and then at this particular area, it becomes liquid. But why do you find the outer core to be solid again? Because the rocks that are present in this region, they need more melting point. And you see, the pressure at the outer core and the pressure at the inner core, is it same? Why is it not same? See, imagine this is nothing but your earth, right? If I have to draw, this is your earth, और ये आपका inner core हो गया. A material which is lying at this depth will be experiencing the weight above it. Clear? And a material which is at outer core will only experience weight of this column. So the materials which are present in the inner core, they experience extreme pressure, and they are the purest materials. Now that materials, they need little more temperature to be liquid. So the fundamentality behind why is the outer core solid, why is the outer core liquid, and why is the inner core solid is because the concept of partial melting and the concept of purity is involved. Now in more detail, in the main classroom we will study about what are the different types of rocks present here, what are the different types of rocks present at the upper end. Right? Clear? Come back. Now there is some factual content which you need to know. This factual content is nothing but कौन सा ऐसा layer है, कितना depth तक है. But the principles involved are more or less whatever we have discussed, and little more in detail we'll go. Yes. Okay, continental crust 5 किलोमीटर लगा है, गलत. Yes. ये ओशनिक क्रस्ट है. ओशनिक क्रस्ट का डेंसिटी जो है 5 किलोमीटर. कॉन्टिनेंटल क्रस्ट का डेंसिटी नहीं, थिकनेस 30 से लेकर 70 तक जा सकता है. Right? Now see, this is a broad diagram which tells you what is the density of each layer. Density of each layer, you look into the crust, it is ranging from 2.2 to 2.9, and within the crust also, the upper part of the crust will have less density, and as you go deep into the interior, you'll have higher density. Now, upper mantle 3.4 to 4.4, lower mantle 4.5 to 5.6. In between these layers, you will find asthenosphere. Asthenosphere का density है 3.2, right? This is where you will get the asthenosphere. Just a minute. So, right? And then outer core 9.9 to 12.2, inner core, it keeps on varying. It's a range. For example, you take ये outer core है. Here, this part of the layer might be having 9.9. Now you go little inside, you will find 10, maybe 11. It's like this. So that's why a range is given. Now there are people who have studied, the difference in between these densities and why is this density happening, and there are some discontinuities named after them. So broadly speaking, these discontinuities are nothing but you'll get to see Conrad discontinuity. Conrad discontinuity, in literal terms, discontinuity means when a wave is traveling through one particular layer, the speed of the wave is not same, and all of a sudden there you got to see some change. Right? Now the layer of change, the change wherever you are seeing, that is nothing but discontinuity. Right? So Conrad was the one who studied the discontinuity between mafic layer and felsic layer. Mafic मतलब जो upper part of the crust है. Felsic मतलब lower part of the crust. It's like this. See. ये आपका continental crust है. Within the continental crust, this is upper part of the continental crust, and this is lower part of the continental crust. Let me show you a different diagram which will help to understand the mafic and felsic layer. Look, same continental crust, upper part of the continental crust and lower part of the continental crust, and he said whenever the wave is passing through this layer, there is some variation in the speed also, and it is here you will get to see some variation in the density also. And he said ये continuous नहीं है, discontinuous है. And this is the person called as Conrad. Conrad studied the difference between upper and lower crust. Right? Now this is called as felsic, this is called as mafic. Right? Right? Now come back. If you look into the discontinuity between, you see the same diagram here. The discontinuity between crust and mantle जो है, that is your moho. Like that, up you have a Lehmann discontinuity, Gutenberg discontinuity भी है. So mostly these are factual contents. Will not be taking much here. Only in the main classroom we'll discuss. Right? Now my idea is to tell you, just a minute, the variations in the density. Upper mantle thickness 720, lower mantle around 2000 plus, Outer core 2000, inner core, it is very small in size. And you know, inner core also rotates. The rotational speed of the inner core is different. In fact, it moves faster than the Earth, you know. Recently article hai, the speed of the rotation of the inner core might have reduced. This is the article, and it may have stopped, but stopping cannot happen. That is still in a discussion. In the main classroom, we'll discuss in a very extensive manner why the inner core rotates, why the inner core temperature is very high, and why is it still a solid. These things we'll discuss in detail, right? Come back. Now here, you need to understand the basic tenets of the formation of the plates, right? So I told you, you have the continental crust and the oceanic crust is made or divided into different plates, right? Those plates can be continental plate as well as oceanic plate on the basis of the nature or the size of the plate it maintains. So let me show you the plates here, how exactly the plates are present on the surface of the Earth. Just a minute. Look. See, your entire Earth is broken into multiple pieces, right? And till what depth? The depth ranges from 10 to 30, 40, 50, 90, 100 kilometers. That means, I told you there is a lithosphere, and lithosphere is floating on the asthenosphere, or else lithosphere is trying to balance itself on the asthenosphere. And here, the lithosphere plates are divided into major plates and some minor plates. You look here, this is a Pacific region, Pacific Ocean. This is your Pacific plate. And you look into Africa region, this can be your African plate. Broadly speaking, there are some major plates and minor plates. About each plate we'll discuss in detail in the main classroom. But here, I'll give you an idea whenever these plates, when they come and collide with each other, what kind of landforms you'll get to see, right? So let us try to understand an interaction of a plate between Nazca plate and South American plate, right? South America is a continental plate, Nazca is an ocean plate, right? So see here. Imagine, ये है आपका नाज़का प्लेट, नाज़का, एंड ये है आपका South America, right? So if you look onto the, broadly look onto the globe also, you will find that this is your South American plate, and Nazca plate is somewhere here, right? To be more specific, it is like this. So if you zoom into the interior of the Earth, even then you can see the plate boundaries also. Can you see this irregular line? It is nothing but a plate. Now whenever an oceanic plate, this is your oceanic plate, this is your continental plate, right? Whenever there is an oceanic plate and a continental plate which is interacting, it will be like this. This is your ocean, this is your oceanic plate, and then you have a continental plate. Right? So which density is more? This is your South America, and ये आपका Nazca. Right? Which density is more? Oceanic plate density is more. Thickness क्या है? 5 किलोमीटर. Thickness क्या है? Near about 60 kilometers तक है thickness. So if these two plates are moving against each other, if this plate is moving in this direction and if this plate is moving in this direction, in this particular condition, you will get to see certain kinds of landforms, right? What are they? Trenches, right? Trenches देखने के लिए मिलता है क्या? ये North American plate and this is your Nazca plate, right? Sorry, South America, thank you. South America and Nazca. Now, whenever these two plates are colliding, it is actually the more denser plate, it will go into the mantle. Now, while it is going into the mantle, there are 2 or 3 processes which you need to know. इस प्लेट के अंदर पानी होता है, हर एक प्लेट के अंदर पानी होता है. Now, whenever that water, it is getting, imagine this particular plate while it is sinking into the asthenosphere. ठीक है? To be more specific, what is all this? Beneath this layer, what do you get to see? Right? What is this? Mantle or hot molten magma is there. It is this plate which is getting into this layer and then gets burnt off or else melts. Why is this melting? It is okay. मेरा क्वेश्चन ये है, मैंने तो कुछ टाइम पहले ये कहा था, यहाँ पर आपका एस्थेनोस्फीयर है, right? If this is your lithosphere, beneath this you will have asthenosphere. And what is the density of the asthenosphere? Then this should float over this, no? My question here is, sir, if the density of the oceanic floor is lesser than the asthenosphere, why is the oceanic floor going into the asthenosphere or going into the mantle and melting? It should actually float, right? Temperature of the asthenosphere is so? So temperature of the asthenosphere is higher. This is one point I got from you. And second, it is plastic soft in nature, right? But density is more, no doubt. But still, even in spite of this, this material should be floating over on this. Why is this going and melting there? For example, I have an iron. Yes? So let me give you an example. This is iron. ये मान के चलो, मैं mercury का bottle लेके आता हूँ या mercury का mug लेके आता हूँ. If I drop this, it will actually float. Why? Because mercury का density ज़्यादा है, तो iron float करेगा ही. The partial melting. See here, the process of partial melting takes place. And in this partial melting, there are 2 processes that are happening. One process is that here, this plate will be having some water. In the general studies and all, you will not study in this depth. It will be having some water, right? When this gets heated, the water will get pressurized, right? The water will get pressurized and also its melting point reduces. This part of the plate which is going down, its melting point reduces and then it will start to melt. ये सब melt हो जाता है. As it starts to melt, it will rise, right? And then it punctures the continental crust in various angles, and here you got to see some volcanic material, right? It is because lowering of the melting point. Why is this melting point lowered? Melting point of what? Melting point of the oceanic floor is lowered. I mean to say, imagine this melting point in normal times is around 1000 degrees पे melt होगा, but लेकिन when it is mixed with water, which is water is getting heated, and then the pressurized water, it tries to come out in that particular point, इसका जो melting point है ना 800 degrees पे ही हो सकता है या 700 degrees पे हो सकता है. Because of that, this entire plate which is going down, when they collide with each other, it melts. As it melts, the material will start to rise. So to be more specific, I'll be showing you, in the previous classes also, I think I've shown you a small video how the magma rises onto the surface, right? If you remember. Now let me show you again. It will actually give you a good glimpse of why is this volcanic mountains are formed along the continental crust and the oceanic crust interaction, especially in the oceanic plate and continental plate interaction. See, interior of the earth, this is your outer core. Material starts to rise. Why is this rises? I'll explain you in some time. But when they start to rise, these plates, they generally move apart, or they come towards colliding towards each other. In this due process, sometimes whenever an oceanic crust and a continental crust, they collide with each other in the form of oceanic plate and a continental plate, it is, see, ये मान के चलो ये आपका कॉन्टिनेंटल प्लेट है, ये आपका ओशनिक प्लेट है. ओशनिक प्लेट, इट इज मूविंग, collision है, it starts to melt here. Why is it melting? Because there is some water molecules which are present in this plate. As and when it lowers down, its melting point lowers. मतलब कम temperatures पे भी burning हो सकता है, and it starts to rupture. Friction भी generate किया जाता है, and that friction will start to rise the material. And here is where you'll get to see volcanic activity. Now imagine this is your South American plate and this is your Nazca plate. Wherever there is collisions, you'll get to see the volcanic activity, right? So this is how the formations of the volcanic activity you will get to see on the continental plates when they are colliding with oceanic plate. Now, whenever an oceanic plate and a continental plate, they are colliding with each other, here you will get to know there are some other formation landforms also, formations of other landforms. What are those landforms? Have you ever heard of accretionary wedges? Dekho, imagine that this is an ocean, right? And this is a continent. This is a continental plate, or else let me put it this way. This is a continental plate, this is an oceanic plate, and if these two are colliding with each other, right? If these two are colliding with each other, imagine this plate, when it starts to move down, it will sink. This is more denser and this is more lighter. As the sinking happens, this plate will start to move down, sink. In this sinking process, don't you think that there are a lot of sediments that are present on the floor of the ocean? What happens to this material? What happens to the material? It also sinks, but लेकिन काफी ज़्यादा material होता है यहाँ पर, sand, silt, or any kind of landform. Not all material sinks. Usually, they will start to accrete here. Now, this material, the oceanic floor, it will further sink. It sinks like this. Imagine if it is further sinking in this due process, the material will get scraped away and they'll start to get deposited here. And this due deposition methods और process में आपको कुछ landforms देखने के लिए मिलता है. ये एक island भी बन सकता है. Sometimes you can also get to see water here. or sometimes you may not see the water, mountains can be there. Now this is the accretionary wedge. These kind of landforms are called as accretionary wedges. But on the other side, the oceanic plate is also melting. When this oceanic plate melts, it starts to melt down. Oceanic plate sinks, it starts to melt down, and then there is rise of material that you will get to see on the continental floor also, right? Now ये है आपका volcanic arcs. आज आप you go and look into the South America. South America has very big volcanic mountains. So these are nothing but Andes volcanic arcs. Andes mountains suna hoga. Now these Andes mountains are present across the coastlines of, they are present on the coastlines of the western part of the North America. It is here. Now how did this Andes form? It is because of the collision of the oceanic plate and then continental plate. They are colliding with each other. Here in this case, your oceanic plate sank down or sinked and they started to melt. You got to see some volcanic arcs or volcanic mountains, and these mountains today are active, still active. But on the other side, there are also some accretionary wedges you will get to see here. Okay? So you go to US also. US mein, you get to see two different chain of mountains. Ek Sierra Nevada plateau is there. In the US, if you see, the mountain chains are like this. Rocky Mountain सुना है आप लोग? Rockies के अंदर volcanic material है. It is here. But here, these are accretionary wedges. Sediments इकट्ठा हो गया. ये आपका volcanic mountains hai. So even you go to Andaman also, you will find them. Even you go to Indonesia, you will find them. So this is how the collision between the oceanic crust and the continental crust take place. And more specifically, if you look into the continental crust as well. Continental crust, best example is India and China. Why don't you find volcanic activity there? It is because whenever equal density materials, मान लो, if this is India and this is China, if they are of equal density materials, when they collide with each other, none of the material can sink. Only the denser material sinks, right? So that's why these two collided and they rise. None of the plate is going and melting into the mantle. That is the reason why you will not find volcanoes. But लेकिन एक time पे volcanic activity था on the Tibetan plate, but today it is no longer active, right? Clear? Now a plate can collide with each other, a plate can move apart from each other, and the plate can slide against each other. So broadly speaking, the interaction between plates can be of three different types. One, it can collide, it can move apart, or it can slide past each other. Now whenever they collide, this is called as convergence. ठीक है? Whenever they move apart, it is called as divergence. Now whenever they slide past each other, it is called as transform movement. ठीक है? Transverse ये भी कहा जा सकता है. So like this can be ocean, this can be continent, this can be continent, continent भी हो सकता है, ocean, ocean भी हो सकता है. Like here also, this can be ocean, continent, ocean, ocean, continent, continent. Here also, ocean, ocean, continent, 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 ocean. These combinations we have to study. किस type की interactions में, what kind of landforms they make? No. क्या? Transform. Oceanic plate, it's not coming up and going down. It's just they are in the same level. Instead of colliding with each other, what do? They come here and they slide past each other. It's like this. This can happen. No. अगर ये ocean है, ये continent है, ocean will have to go down because density ज़्यादा है. Right? It's not about coming up and down. The coming up and down can take place here. ठीक है? I'm using the layman's language here just to give you an understanding. Right? So it's just about either they collide. When they collide, if this is ocean, it will sink and continent will rise. If both are continents, ये दोनों they'll collide with each other and then they rise and they fold. This can happen. Ocean में क्या होगा फिर? Ocean. What happens in the case of ocean and ocean? देखो, ocean floor में ना, it will be like this. Imagine this is your ocean floor and this is also your ocean floor, but there is a break, or else the plate has a gap. In this case, the older ocean floor will sink and the newer ocean floor will be like that. Right? So I haven't taught you the plate tectonics, I haven't taught you the continental drift theory. There's a lot of concepts that we have to understand, but this is only for a general understanding that I'm teaching you. Right? Now let's try to look into the case of India and China. Old wala? Okay, very good question. So I said, imagine that this is your older oceanic floor and this is your newer oceanic floor. Comparatively, older oceanic floor, its density will be more. It is because you have to understand the concept of middle oceanic ridge. Imagine, let us try to take the Atlantic Ocean here. देखो ये Atlantic Ocean में ना, if you see, can you see these kind of landforms? Very rugged topography. This is nothing but middle oceanic ridge. ये middle oceanic ridge में, broadly speaking, you will have plates. The plates are like this. Just a minute. Okay. On this earth, imagine this is an ocean. Right? So beneath the ocean, from the inner core, imagine this is your outer core, the material starts to rise and it can give rise to a divergent plate. In this divergent plate, sometimes here the volcanic material will come out. Right? Wherever this movement of plates are going away from each other, there you will get to see the volcanic activity. Right? Now just imagine that this is your continental crust. ठीक है? ये आपका continental crust है. ये मान के चलो. If this is your oceanic crust, this is your continental crust, what happens between these two plates? This is ocean, this is continent, this is ocean. The oceanic crust will go down or sink, and the continental crust, it will rise up, and then sinking of the oceanic floor will happen. So You have to understand the concept of middle oceanic ridges. Middle oceanic ridge mein, what I'll be doing is I'll be trying to draw this particular area in a new diagram or new slide. See, this is the floor of the ocean, right? From beneath there is rise of the magma material and it has punctured, and then you got to see the formations of the magma. Here, as the volcanic material comes out, it also diverges. Imagine this is a divergent plate. You understand divergent plate? In this divergent plate, see, the new volcanic material or the new rocks are forming next to the divergent plate. So, ये नया बन गया, and little later, what happens to the oceanic floor? It moves apart, right? The position of this oceanic floor, it keeps on moving on to the sidewards. नया ocean floor कहाँ पे बन रहा है? At the middle oceanic ridge. This is your. Here new ocean floor is formed. As the new ocean floor forms, the plate is moving apart. Now this is the oldest part of the ocean floor. This is the newest part of the ocean floor. Temperature of this will be more, or temperature of this will be more. Obviously temperature of this will be more. Whenever a material is hot, its density will be little less. As if the same material, I have the same material, if temperature is hot, temperature is less. Now here, the density of this material will be little less. And as it cools down, its size also shrinks. It is expanded here, it shrinks. So the older oceanic floor density is high. Now just imagine at the other end, you also have an oceanic floor. If these two floors, they are colliding with each other. Imagine this is colliding with each other. In this case, this will sink. On one side, you got to see the rise, and other side, this will go and sink. It is because it is cold. Imagine, or density increases as compared to this. So that's why two oceanic floors, while they are colliding with each other, the older oceanic floor will sink. What if both are old? So their sinking will not happen. It is actually the volcanic mountains, sorry, the oceanic mountains will be formed. But itna old oceanic floors collisions abhi you cannot see at this point of time on the surface of the earth. एक टाइम पे था जब रोडिनिया करके एक बड़ा सा लैंड मास होता था, उस टाइम पे था. बट लेकिन अभी you look into the map, just a minute. You look into the plate tectonics map, you will understand that. Just a minute. Okay, this is not reacting to us. So usually when there is, you look into the tectonic map of the world, the tectonic plate maps, today you do not have both the oceanic floors colliding at many big plates are not there, hardly one or two transform boundaries are there. So ek time pe tha, but and whenever they are there, you generally collide with each other and there's some volcanic landforms you will get to see, right? So this is what is with respect to the plates and the interior. In the next class, what we'll do is, we'll take oceanic continent, 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 ocean, ocean convergence, and the land forms which can be formed through this. And also, the continental drift theory, kya hota hai? This we'll be learning. So we'll stop it here, right? And next class we'll continue. Online, agar koi doubts ho to, you can message. Okay, Rajat, not needed in this detail. See you in the next class. Kya? Ultramafic. They are found in the near to the core. मिल सकता है. Ultramafic rocks can also be seen on the continent as well. But whenever the volcanic material that is getting cooled, it should be cooled it should start to cool at that particular temperature. देखो क्या होता है ना, whenever the material is coming out from the continental crust, if it is 1400 degrees Celsius is there to the volcanic material, while the volcano material is coming out, it gets in contact with the continental crust, it will also melt the rocks, and that rocks has some silica content. ये सिलिका कंटेंट इस वॉल्केनो के साथ मिक्स होगा, तो कलेक्टिवली टेम्परेचर क्या होगा, डिक्रीज होगा. When they collectively decrease the temperature, this material while it is coming up, again it will start to melt the sideways, then again mixing. So usually you will not see ultramafic rocks on the continental crust. You will get to see on the oceanic crust.